gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of March 20th, 2018, and we are looking at the benchmark review, and we're looking at picking effective strategies. Let's get started. So we're looking at number 1. Which of the following shows the slope and y-intercept of the line graphed at the right? And if you notice, that line touches the y-axis at 0,6. Now this isn't a perfect copy of what you have in the book, but it is the same line. So if you notice here, it's asking us to pick the right answer. The first thing we do before we do any math is to use some logic. Since the line points downward, that tells us that the slope has to be negative. You know immediately that the choices can't be C or D. Both of those answers have positive slopes. The slope is 6. So the question is assuming you'd get the y-intercept and the slope mixed up. We're not going to get caught that way. So let's go on to number 2. With number 2, we're finding the slope using the 2 points on the graph. All right, and there is an equation for this. So let's look at our 2 points that we know we have. Looking at that graph, in the book, we have -3, 7. We also have 6, 4 as our second point. Now, my graph doesn't show those 2 points, but the book's graph does. All right, so remember, it's important that you're reading these along with me. All right, so how do we solve this? Well, if we're going to find slope, it's always rise over run. So it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So how does that look? 4 minus 7 divided by 6 minus -3. So if we solve that, that becomes -3 at the top, that's 4 minus 7, and 6 minus -3 becomes positive 9. And -3 over 9 is a slope of -1/3 or -0.33. Now, if you wanted to plug some points in, that's where my line comes from. So if you notice, I've got a lot of decimals in my answer here. This line follows those ordered pairs exactly as you see them. But if you notice, they're only asking for the slope. So as long as we know it's -1/3, we can put down with confidence that the answer is A. The slope is -1/3 and it touches the y-axis at +6. That's our answer. Moving on to number 2. Apply the multiplicative inverse to the following equation. 7x equals -28. Well, what's multiplicative inverse? So the question is, what can we multiply the number 7 by so that we get 1 as an answer? And that's the question anytime we're looking at multiplicative inverse. So I went back to mathsisfun.com, and here's what they say. It's another word for reciprocal. You all have been doing that since 2nd, 3rd, and 4th grade. So if a number is 8, the reciprocal is 1/8. If a number is 10, the reciprocal is 1/10. You multiply them both together, you get 1. So what do we multiply 7 by to get 1? Well, 7 over 1 times 1 over 7 equals 7 over 7. 7 divided by 7 is 1.0. So if we apply that to the equation, it looks like this. 1 over 7 times 7x equals 1 over 7 times -28. And as a matter of fact, when we divide by 7, we're going to come out with the exact same answer. 7 divided by 7 is 1. -28 divided by 7 is -4. Here, the answer is J. The answer is J. This problem goes on for a while. It says there are 12 different varieties of oak trees. This is 8 fewer than 4 times the number of kinds of pine trees in the state. Our equation is 4p minus 8 equals 12. How do we figure out what p is, how many kinds of pine trees there are? All this is asking you to do is solve the equation. And sometimes, instead of just giving you a problem, it'll give you a bunch of words. So let's solve the equation. 4p minus 8 equals 12. 4p minus 8 plus 8 equals 12 plus 8, and that's additive inverse. We're going to add 8 to both sides and cancel out that -8 term. And we have 4 times p equals 20. Divide both sides by 4, p equals 5. All right, that means that there are 5 different kinds of pine trees in Virginia. The answer is B. The answer is B. Number 4 asks us, which of the following is not a true statement? So it's got here 7 is less than the square root of 50, which is also less than 8. Then we have G that says 4 is less than the square root of 23, is less than 5, and so on and so forth. You might think that your strategy is to find the square roots of each of the numbers in the middle, and you could do that. What this is asking you all to do is remember your perfect squares. So instead of just using the obvious strategy of, oh, let me take my calculator out and punch out the square root of each one of these, strange numbers, I'm just going to use what I already know and use my perfect squares. So let me show you what I mean. Right here with f, 7 is the same as the square root of 49, and 8 is the same as the square root of 64. Now I'm just reading my bottom line. The square root of 49 is less than the square root of 50, which is less than the square root of 64. That's a true statement. All right. Now, could I find the square root of 50? Of course I could. And would it be between 7 and 8? Yes. But that would mean I'd have to take time and punch through my calculator when I don't have to. This method is a little bit faster. Let's see. Right here for G, you've got 4 is the same as the square root of 16, is less than the square root of 23, which is also less than the square root of 25, which is 5. This is also a true statement. Going on to H. Now it looks like we've got one that doesn't make any sense. 9 is the same as the square root of 81, which they're saying is less than the square root of 78. That right there is going to tell you something's definitely wrong here. All right, so we think H is the answer. Let's just check J to make sure. So we have 11 is the same as the square root of 121, which is less than the square, that should say the square root of 133, which is less than the square root of 144. And this is a true statement. The answer here is H. The answer is H. All right, going on. The last one here says, which list contains only rational numbers? So what is a rational number? It's any number that can be expressed as a fraction. All right, so our strategy here is to eliminate all the lists and our answers with irrational numbers. That's it. So the key here is, can you show the number as a fraction? If not, the number is irrational. And if you have an irrational number, you can mark that out as a possible answer. So let's go down through our choices. I'm going to start with B, just because I see pi and I know pi is an irrational number. So pi goes on forever. It cannot be expressed as a fraction. Don't get this confused, because 22 over 7 is not pi. 22 over 7 is an estimation of pi, not pi itself. Okay? Pi is 3.1415. It goes on forever. C contains the square root of 10. You cannot express that number as a fraction. All right? That can't be expressed as a fraction. C is not the right answer. D contains 2.1686868, and it goes on and repeats forever. We can't express that as a fraction. So the answer here is A. A is the only part of this list that contains only rational numbers. The square root of 32 is a decimal that terminates, and yes, you can express it as a fraction. So that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.